Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. Thank you to everyone that made the last video such a success. I really do appreciate you watching that. If you have not watched that video before you watch this one, you might want to drop by. That was a pretty cool fix. So anyway, today's video is another fix video. It's about when you put a pin in a hole and you want that pin to be a little bit tighter than it was, how it turned out. Well, you know, there's a bunch of different ways to fix that. And I'm going to demonstrate, illustrate, and then actually practically do it 7 different ways to make that pin tighter in that hole. Some of them have more structural integrity than the other ones, so by all means, if you're going to attempt any of those, make sure you know the final application. You do not want anything going wrong at the 11th hour and really causing a problem. So know the load on the pin, know the demand, know the lifespan, just get it figured out before you do it. But as a hobbyist, every once in a while you ream a hole, you say, okay, well, it's going to be a nice press fit for this little dowel pin, and it's not. So what do you do at that point? That's what I'm going to tell you about. First thing we're going to talk about is the hole. How do you fix the hole? Easy. Cross section of the hole. Here it comes. Through hole. The hole is too big. You want to close that hole up so it grabs a hold of the pin for a fixture, for a part, for a model, whatever. You want to close that hole. Number one thing that most guys will cheat and do is take a ball bearing about twice the diameter of the hole and lay the ball on top of that hole. Give it a smack with a hammer. Boom. When you do that, you get a bulge on the inside of the hole right there. That effectively closes the hole. If you tap it, try it, tap it, try it, you can actually dial the size of the hole into the size you want, or you just give it a really good smack and re-ream it to a smaller size. Problem solved. That is probably the most common way to fix an oversized hole. Ball it. Drawbacks to that? Well, drawbacks to that is if you didn't know that the hole was oversized to begin with, and you chamfered it, like most reasonable craftsmen will. Put a nice break edge on the hole. Boom, now when the ball sits there, it sits on these points. And you can smack that thing till the cows come home because nothing's going to happen, or it's going to be so obvious it's not even going to be funny. So what do you do now? Well, you take a punch, you go down inside that hole, and you ding up the inside of the hole like an internal knurl. Give it a smack. 1 smack, 2 smacks, 3 smacks, 4, whatever it takes. And what it will do is it'll give you a ding here, and it'll give you an elevation there, and it'll come out exactly the same way, same feature as a ball. Now, what you need to keep in mind is when you do this, depending on how much slop you have between that pin and that hole, if you have all of your influence on one side of the hole, like this technique, it may skew the pin. So do it in several places, or know what type of fit, what type of final product you're allowed. That works very well. It's invisible, and it's also applicable to a hole with a chamfer on it. So do that in a couple places. Nice high-speed steel blank. Wedge it in there, lean it against the other side of the hole, give it a smack. Out comes that little footprint right there. Put a bunch of them. It's not going to hurt anything. Next option. This one is not invisible, and to look at it, you'll know exactly that it was a repair, but do it with a center punch. Come around the periphery of the hole. Put a bunch of center punch marks around the outside of the hole. Stay close to the hole. Hit it several times. It's going to close the hole in. It's not going to be a continuous loop like a ball will give you, but it will close the hole. It will also be terribly obvious that you did that. So if it doesn't really matter, that is certainly an option as well. That is option number 3 to address the hole. I'm not going to get into plating the holes or building it up with silver solder or weld. This is, gotta get it done right now, so grab something, make it happen, and keep moving. Plating works really good if it's a structural component, if it really needs to be pressed in there and dropped in there. I'm also not going to get into cryo fits. If you're going to freeze something and heat something up, That works very well as well, but if the hole's blown, chances are a cryo fit's not going to work for you anyway. And if you do a cryo fit, don't waste time when you pick the piece out of the dry ice, because it's on thin wall bushings and stuff, pins. It's going to absorb the heat from your hands, and you're not going to get it all the way in. You're going to blow it. All right, that's the hole. 3 options for the hole. The pin itself. What can you do if you don't want to mess with the hole and you do want to work with the pin? Well, the first thing that you would think about is, well, knurl it. Straight knurl is better than a diamond knurl. Diamond knurls seem to just shear off as they get pressed in. Straight knurls seem to kind of broach the hole as the pin is being pressed into the hole, and it bites real well. So to anybody that's ever used a screwdriver as a chisel, not me, guilty. When the handle blows up and when the handle comes flying through the end of the plastic because you beat on it with a hammer, you'll see that the side has been coined out, little wings on it. That serves 2 purposes. It keeps it from rotating and it keeps it from pulling out. Same thing with a straight knurl, but on a much larger scale. And I'm sorry, I do not have a straight knurl in this building. I thought I did, but I do not. So I'll try it, but I'll try it with a diamond knurl. So when you see that in the video and I'm talking about straight knurls, please be kind with your comments. All right. That's one. Number 2 is to swedge the end of the pin. You have a, let's say this is your before pin right here. Hold about the 1/8 of an inch of the end of the pin in a vise. A lot of guys are going to go, oh God, don't use a machine vise. You know, I use my machine vise for everything. It's out there. It's a tool. Put that pin in your vise. Squish it. You're going to get a double D shape on the end of this pin. The sides are going to bulge out. Press it in, give it a smack. It's going to hold really tight. That swedging techniques works very well, and it works well. It's, you know, if you have something that's glass hard, your options are limited. So this is for softer materials. You can also, to secure a pin in a hole, center punch the periphery of the hole, very much center punch the periphery of the pin, very much like you would have center punch the perimeter of the hole. Put it in a V-block, use an automatic center punch, use a whatever kind of punch you have. Put a bunch of elevations in it, and this causes a displacement of the material as if you stepped in a nice flat piece of mud. You're going to have a footprint in that mud, and around your footprint you're going to have a little mound because you've displaced that much of that mud, right? Same thing with a center punch. The more punches you have, the more displacement you have, the better grip you'll have. So that's a good one. Next one is a cross dent with another pin, a harder material pin. If you squeeze these 2 pins together, you're going to get, let me see if I can figure it out then. You're going to get a dent in the bottom pin from the diameter of the pin that you just squished it with. That is also going to give you a uniform squish. Not my favorite one, but I've done it. I know that it works, and it'll hold on nice and tight. So I've prepared a blank out in the shop. I've got 7 holes. I've got 7 pins. All the pins drop through those holes. I'm going to affix 7 pins in 7 holes, 7 different ways, just to prove that what I just said does in fact work. So let's take a walk out of my shop, which is about 100 degrees today. It is Texas, and make it happen. This hole is about 2.5 to 3 thousandths oversized, and the first technique I'm going to use is the ball technique. These do have a tendency to take off, so be ready for it. There you go. It's already tighter. A little bit more. Okay, number one, ball technique. Second technique will be the punch technique to deform the inside of the hole. Let's chamfer the top of this just to prove that it does work. I will make every attempt to ding up the far side of the hole right in there so you can see it. The punch itself is just a piece of steel ground at a slight angle and still sharp. I'm applying pressure this way to keep it canted in the hole, and I'm going to smack it. Third technique on this hole is to center punch the perimeter and close it up. Those are three very common techniques for closing up holes. Now let's address the pins. The next hole in line I'm going to do with a knurl. I'm going to take a standard pin like this, and with a little voodoo magic we're going to turn it into a knurl pin like that. Dropping it into the hole, it will not fit. It stops. There's no question about it. I'm going to put a slight chamfer on it to give myself a lead, and then I'm just going to hammer it in. Like I said inside on the board, a diamond knurl is not suggested because chances are this is just going to broach the top of the hole and fail miserably. But I think you'll get the idea. Let's see what happens. This one is exceptionally tight. Of the three that I just did, this one has the most integrity by far. No doubt about it. Rock solid. Next pin in line will be swedged. I'm going to take this out actually and crush the end of the pin, drive it in. This will be protruding from the opposite side of the plate. Next hole in line is back to the center punch. We're going to do the same thing to this pin that we did to this hole right here. We're going to put a series of center punch marks around the outside, drop it in a little bit, and let the center punch marks take over. There you go. Extremely solid technique. Of the 6 that are already installed, I would say that the knurl and the one with the perimeter center punches are probably the toughest ones to drive in. The last one, I'm going to take the punch that I used to ding the inside of the other hole and lay it across this and hit it with a hammer. It's going to give me that scallop moon-shaped dent. I'm only going to do it on 2 sides. We'll see what happens. That is also a very rigid technique. Now, if you have a very deep hole and the pin is thin enough, you can actually bend the pin and let the non-linear condition of the pin be the interference. But I think it gave you something to think about. We have 7 pins strained in these holes 7 different ways. So I hope you got something out of that. Thank you very much for tuning in. It is time for a cold drink. Joe Pye here at Advanced Innovations in Austin, Texas. I'm out.